Hello. Today's topic is metal ion indicators in complex titrations. Metal ion indicator, as its name indicates, it's a substance, a compound whose color changes when it binds to metal ion. And this metal ion indicators will form only a weak complex. That should be noted that they will form only a weak complex with metal ions present in the solution, which has a significantly different color from the existing existing outside complex, from the color which is existing outside the complex. So 2 points to be noted: that the metal ion indicators are compounds which form a very weak complex with the metal ion, and this complex will should have a different, which should have a significantly different color with the form existing outside the complex. Based on the concentration of metal ions, these change their color, which indicate the end point of the titration. These are also called PM indicators, and these PM indicate with this name, that is PM indicator, is given since this indicator binding is pH dependent. Metal indicator complex, which has a color 1, and when this EDTA is added to this metal indicator complex, metal EDTA, which is a chelating ligand, which will form a stable complex with the metal, and this metal EDTA complex, the indicator will be replaced by EDTA, and the free indicator will be formed, which has a significantly different color too. For example, magnesium, we are using eriochrome black tea as the indicator, and this magnesium eriochrome black tea complex, which has a wine red color, and this, when EDTA is added to this complex, magnesium EDTA complex will be formed, and at the end point, free indicator, which has a blue color, will be formed. Which are the requirements for a compound to be a metal ion indicator? As the compound, as we have already done, have said, the compound must be chemically stable throughout the titration. It should form a 1:1 complex with the metal ion, which is weaker than the metal chelate complex or metal EDTA complex. If the chelating ligand used is EDTA, color of the indicator and the metal complex indicator must be sufficiently different, and the color reaction should be selective for the metal being titrated. The indicator should not compete with the EDTA. These are the conditions. So, indicators which are generally used, commonly used metal ion indicators, modern black 2, which has a color change of red to blue, which works in the pH range 6 to 7, and the metals which can be detected using this indicator is calcium, barium, magnesium, zinc, cadmium, manganese, lead, and mercury. The other indicator which also work in this pH range are eriochrome black tea and solochrome black tea. Muroxide or ammonium perchlorate is another metal ion indicator which has a pH range of which works with in the pH range of 12, and which changes from violet to blue. Calcium, copper, and cobalt are the 3 indicators. Catechol violet is another metal ion indicator which changes color from violet to red, which works in the pH range 8 to 10, and the manganese, magnesium, iron, cobalt, and lead are the metal ions which can be estimated using this catechol violet. Methylene blue is another indicator which works in the acidic pH, which is 4 to 5, and the color changes from blue to yellow. lead, zinc, cadmium, and mercury can be detected. At the same time, thymol blue, which works in the pH range, some basic pH range, 10 to 12, and the color change is blue to gray, which is also can be used to estimate the presence of lead, zinc, cadmium, and mercury. Alizarin, alizarin red, it's also called alizarin red, which is changes from red to yellow, which works in the pH 4 to 3. 4.3, and lead, zinc, cobalt, magnesium, copper are the metal ions which can be detected using this indicator. Xylenol orange is another commonly used indicator, which is also used in acid-base titrations, and it is when it is used, difference is that when this Tylenol orange is used in pH range 1 to 3, it will be can be used to detect bismuth and thorium. And otherwise, if the pH changes to 5 to 6, it can be used for the detection of cadmium and mercury. And the color change of Tylenol orange is from lemon yellow to yellow. And let us discuss the structure and structure of some common indicators. That is, a rheochrome black tea has the structure like this. In acidic condition, H2 indicator minus, it is acidic, which is wine red, and H indicator when it is free, it is it will H in IN2 minus, it will be neutral, which has a blue color. Then basic conditions, its color changes to orange. Rheochrome black tea is an azo dye, and it in 3-protonated form. It is blue in color, and it turns to wine red when it complexes with calcium, magnesium, or other metal ions. Rheochrome black tea has also been used to detect the presence of rare earth metals. Calmagite is another indicator used, which is as in acidic conditions, it is red. In neutral condition, it will be blue. And in basic conditions, it will become orange. And the pH range is 8.5 to 11. It works in this pH. And calcium, magnesium, and cadmium can be analyzed using this indicator. Another metal ion indicator, which can be used in titrations, complexometric titrations, is muroxide. It is a complexometric indicator most often of calcium ions, but also can be used for copper, nickel, cobalt, thorium, and rare earth metals, and which acts as a tridentate ligand, which will form a weak complex with this metal ions. And in acidic conditions, it will be red violet, and in neutral condition, it will be violet, and it turns to blue. With other metal ions, muroxide forms a yellow complex, helping differentiate between calcium and other metal ions. So we can use muroxide for the estimation of copper, nickel, cobalt, thorium, etc., rare earth metals, etc. But with calcium, it will form a red violet complex, and but with other metal ions it will form a yellow complex, and we can detect the presence of calcium using this indicator. Bromopyrogallol red is used as a complexometric indicator for the determination of bismuth, cadmium, cobalt, magnesium, and manganese. It is used as an indicating reagent for rare earth metals. This indicator is used when complexometric titrations are carried out in presence of quaternary ammonium salts. It is used when quaternary ammonium salts are present in solution. Then xylenol orange is another indicator which is also used in acid-base titration. It is used to determine complexometry for bismuth, thorium, zinc, cobalt, cadmium, lead, zinc, and tin and nickel. And the color changes from orange to red to lemon yellow. And orange organic reagent used as an indicator for metal titrations of these metals. And this is the structure of silinol orange. And then pattern and readers indicators. This is calcium carboxylic acid, which is called pattern and readers indicators. And the structure of the indicators there is like this, which is as seen in this. It is an azodide that is used as an indicator for complexometric titrations of calcium and EDTA in presence of magnesium. It is specially used for the titration of calcium in presence of magnesium and calcium indicator complex, which has a pink red color, and the free indicator is blue in color. This method of complexometric titration is dependent on pH of solution being sufficiently high to ensure that magnesium ions precipitate as magnesium hydroxide before this indicator is added. So before adding indicator, we are adding this amount, making the solution pH of the solution alkaline to precipitate magnesium ions, and that is masking by precipitation. After that we are using this indicator. And barium in blue, which has a structure like this, is used, which is also used as a metal ion indicator for iron. Iron 3, this is a redox indicator, also which can be used in complexometric titrations, which changes from colorless to violet blue, and this can be used for complexometric titrations involving the estimation of iron. That's all about the complexometric indicators or metal ion indicators. Thank you.